We are going to solve LRU cache Leetcode problem, which is a medium problem. So the problem says that we need to create a data structure that follows the constraints of a least recently used LRU cache. So we are given the capacity of the cache, and we are going to perform operations like get and put. So we get particular element based on the key, and we put a value based on the key, and we have to write the functions get and put, and each of them should run with O of 1 average time complexity. So the solution for this goes with a doubly linked list and a hash map, right? So the core logic is something like this, where so assume this is our linked list, and the idea is we are going to create two pointers for us. One would be the left and the right, since it's a doubly linked list. And what we are going to do is we are going to consider the left side as the least recently used and the right side as the most recently used of the values, right? And what we are going to do is we are going to have a hash map which stores the key of whatever we are going to put, and the value is going to be a node, right? Since it's a doubly linked list, we are going to create a node, and the value of that node is going to be the key value pair, right? And we can access it through the key. So that's what we are going to do. Now how this actually works is we'll just go through the example given to us. So we are given a capacity 2. That means we can have the capacity to store only two values. That is something like this. Once that happens, we need to either we need to effect something from the list and add something new. So in this case, if you see, I put 1, then I put 2, then I do get 1, and then I try to put 3. But if you see, I've already used 2. The capacity is complete. I've used all the capacity 1 and 2, so it would be 1 and 2 over here. Now when I try to put 3, I need to decide which one to evict from the doubly linked list. And the way we decide which one to be removed from the linked list is the one which is on the left side, because that is the least used, right? And we keep whatever is the most recently used, and that's the idea behind the LRU cache. And we keep which has always been used. So let's go through this example. So what's going to happen first is we are given a capacity of 2. So we have the put method, we put the value 1 and this particular one. So we come here, we put it on the right side because that's the first element. So this is a doubly linked list. Left is connected to the right, and we just added this right now. So what is going to happen to the pointers? Left will be connected to the this particular node, and this particular node will be connected to the rightmost node, rightmost side. And now we have done this, right? So first operation is done. The second operation is 2 again, is put again. So we are going to put 2. So we put it on the right side of the doubly linked list. So this is how it's going to be. So I put over here now. Now we have two elements. The capacity is full. The next time what is going to happen is when we want to put something, we need to decide whether to evict 1 or whether to evict 2. How do we decide that? We decide based on the times either one of them is called. So the next operation that we have right now is get. So I'm trying to get this. Now once I do a get operation, I know it has been called, so I need to move my doubly linked list. The elements of the nodes in the doubly linked list should be moved because I'm trying to get it. If I get this, now this is not the least recently used, this is the most recently used, because we have used this once by putting it, we have used this one by putting it, and the second one is now the operation that was asked, that is 1. So what we are going to do is we are going to remove this and shift this value over here. Okay, so this 1 comma 1 is removed and we put it over here, right? So now the scenario is I put 1, I put 2, I do a get of 1, and the most recently used, the least recently used till now is 2, right? Because we have done get once. The next time when put is coming here, which is telling us to put the value 3, now we can make a decision which to be evicted. We always evict something from the left, right? So we remove 2 and we add 3, right? So 2 has been removed and we add 3 to this, right? After that, what's going to happen is it's asking for get. It's going to tell 2. Now we just check the hash map whether we have it or not. We don't have to because we just removed it, right? Because it was the least recently used. So the answer is going to be -1, which is correct. After that, it is telling to put 4, right? So what are we going to remove now? We are going to remove 1. Okay. So we remove this and we add 4 comma 4. Now we have the capacity is again full. The next thing that we do is get. What is get? We are trying to get 1, but then we just evicted 1. So the answer is -1 because it doesn't exist in the hash map itself. The next time is get. What do we get? 3. So 3 is there and we make this on the right because it has been called. We remove it from the left and put it over here. After that we do get 4 and then again we take this over here. So that's how we get 3 and 4 over here, and we just keep on changing, interchanging and removing and adding the nodes in the W linked list to understand which one is the least recently used and which one is the most recently used. Okay, so that's how the algorithm works. Now if you see, I've been saying that we need to remove and we need to add, so we need 2 different functions for this. So it's going to be something like this. Going to be remove a node, and then we need something to add. What is this add? We are going to add it on the right side, right? Either we add it because it's a new element, or we add it because we have removed it from the least side to put it on the right side, right? Okay, so that's this particular function that we are going to use. So that's how we start. Now the next thing would be we are using a W linked list. So let's create the class, the nodes. So I create this. We have a key value, and what is inside. What we are going to have is we need 2 pointers. One would be the previous pointer, the next and the next pointer, right? So self dot previous, it's none for now, and then self dot next is going to be none. Then we need self dot key, which is how we are going to assign the value to that particular key, and then we actually have the value as well, which is the input. Okay, so that's how the node will look like. Now the initialization part would be capacity. That's fine. Then I said we need a hash map because they have said that we need average as O of 1. So hash map is the best solution for us here, which is like this. And now what we're going to do is we are going to connect. So initially we don't have anything, right? So this is not there. So we just connect left, and then we just connect left and right, something like this. So to do this, what we're going to do is self dot left is equal to a node. So these are some dummy nodes that we are going to create. And now we add the pointer. So self dot left dot next is going to be equal to self dot right, and then self dot right dot previous is going to be self dot left, right? So we have connected this connection. So left dot next goes to self dot right, and right dot previous is nothing but self dot left, right? So removing and adding, we will see that in a bit. Now just let's add some of the few things that we need to add over here. So when we try to get, we just need an if condition. So if self, let's add that. So if the key is in self dot hash map, so if it's already in the hash map, and what we're going to store in the hash map is something like this. So map is going to be we have the key, which is going to be like something 1, and the node is going to be 1 comma 1, right? So the key value, and this is the key, which is the input. In this case, it's going to be like 2 here. Okay, so if the key is in the hash map, what we are going to do is getting the node. We are going to get the node, the entire node. Okay, this is what we are going to get over here. So the node is going to be self dot hash map, since it exists, so it's going to be key. So we got the node. What we are going to do is, if we are trying to do a get, it means we have these two elements or any one of the elements already inside the W linked list, right? Something like this. So I'm doing a get. I do a get on the 3 which is there in the hash map. What I'm going to do, if it's a get, I'm going to remove this, right? So that's a remove. So what I'll do is self dot remove. What I'm going to remove is the node. Once I remove it, I'm going to add it again. I'm going to add it on the right side because that's the most recent layer. So this particular add. So I removed it. Now I'm adding it again. What am I adding? The node. That's it. Once I do this, I also need to return whether it's the whatever the value is. So the node's value. So either it's -1 or 1. So if it exists, it's going to be node.val. And if in this case, this particular -1 is the answer that we need to give, because we did a get of 1, which is does not exist in the hash map, it's going to be -1. So that's the -1. Right? Does that make sense? So that is done. So that's the get. So that's the only thing that we're going to, we'll see how to implement this. Okay, so for now it's just adding and removing. So we remove it from the left and add it on the right. Now to put it, so what we first need to check is whether it is already there in the hash map or not. Why? Because we could change the value of the key. So if it's like 2 comma 2, later on we want 2 comma 8 something, right? So we just check if key in self dot hash map, if it is already there, we remove the node, right? We get the node. You know what, let me just copy this. I got the node, and then I just do the same thing, because if I'm if I'm updating the value as well, I'll just remove it and put it on the right side again, right? So the same thing again. I think I just do return, and I think I also need the node dot val is equal to the value, right? So if it is already there, I'm updating it. So if it's 2 comma 2 and it's going to be 2 comma 8 later, so the value is uh, changed now. 2 comma 2 becomes 2 comma 8, right? So that's one condition. The next condition is, let's say the capacity is full, which we already saw, right? So here the capacity is full and I try to put something. I need to remove this, right? So I need to remove this because the capacity is already full. So what I'm going to do is, so if the capacity, which is nothing but length of cell dot capacity, equal to self dot hash map. Oh, I'm doing the other way. It's capacity with the hash map. So if the hash map has the same elements that we are trying to put, what I do is I just delete it from the hash map. So hash map delete the, what do I delete? The value that I'm asking for. So that's going to be dot left dot next dot key, right? So I need to remove it from the hash map. So I take the next element from here, because it's always going to be the left one, right? So the left dot next dot key is going to be 4, which I need to remove from the hash map, right? So that would be the actual key that will be removed from the hash map, and then I just remove the node itself, right? So I've removed the node from this, and I've removed the node from the W linked list, and now I'm also removing it from the hash map. Now, out of all of this, if the element that we're trying to put is does not exist in the W linked list. What do you do? We just create a new node, right? So node is going to be node, and the input is going to be whatever the input is given. Okay, and then we add it to the hash map, and the value is going to be node, right? So that's what we saw over here. This is what we are creating now in the put method, right? I should have written the put method first, but then the get method is just a bit easy to understand, and then just add it. Where do I add it? On the right side, okay? The node, which says it could be here, right? So I think this is the most part of the solution that works based on intuition, that we remove it and we add it. Now we actually need to write the functions remove and add. How do we do this? So how do you do in a single linked list? That's how we do it here as well, right? So we need to remove it from here and put it over here, right? That's what the remove method is going to do. So how it's going to look like is, we need to remove this. So node, this is the node, right? So node dot previous dot next. So nodes previous next, which is the arrow, is going to be node dot next. So the node dot next is going to be attached here. Okay. All right. So if it's only one, so the next of this particular node goes to the previous's of next, right? And once that is done, that's only one direction. So the other direction is going to be node next dot previous. So node next previous is going to be nothing but node dot previous. I hope you understand this. You just try to. I've written this in a very short way. So generally, you can do a variable that node dot prev is previous node, and then the previous node is next is like this, and that's another way to write it. This is just better to write it, but difficult to read maybe. So just try to understand this, how this works. Once that is done, let's do the add part as well. So how we are going to remove, so we have removed it. Now we need to add it over here. So adding it to over here is based on this. So it's right of previous. So the left node from the right next is going to be the actual node, right? So it's going to be self dot right dot previous dot next, right? So from the right side, I look at the previous node and I have to point it to the node, right? So the node is now pointing. So one direction is this. The next part would be, I have already made this connection. So the previous of this node is going to be the self, which is the right side dot previous. Okay, so that's one connection. The second connection that we need to make for the node is, so the next of the node which we are going to we are adding is just pointing it to the next, right, which is the right. Going to be here self dot right, and what I'm going to do is the previous part of this, we are not linked this, the previous part of this should go to the node. So it's going to be self dot right dot previous goes to the node. So this part, just try to write it down. It's difficult for me to show it over here, but that's how it works. Just try to read through it, you'll understand. I think the get and the put method are pretty basic, and like if you just remove it, you just add it, then you just check whether it is same or not. If it is same, I need to evict it from the left, and you just delete it from the hash map. You also remove it from the W linked list. If it's not there, you just add a node to it on the right and use the functions, right? So let's try to submit this. So it's submitted. Yeah, so that's how it runs. But try to go through this. It might be a bit confusing at the start to understand, but yeah, that is the code for LRU cache. Thank you.